Hi there, my name's Scott, and today I'll be installing this Rebel LS engine management system and terminated wiring harness into this LS-powered race car. This is going to help you to see how easy it is to get your LS swapped project up and running with the Rebel engine management system. So first things first, what is it and what does it do? Once you've installed your General Motors V8 engine, your LS1, LS2, LS7, your Gen 3 or Gen 4 series LS engine into your project car, and you've done all the hard work, all the mechanical work, you're still going to need all the electronics so that when you hit the key, the thing starts and runs. That's where the Rebel LS comes into it. This is a dedicated Gen 3 and Gen 4 LS engine management system with a terminated harness that's specifically designed to plug straight into your project as easy as possible. There's a really simple wizard in the engine management software that asks a bunch of questions about your project. Then hit the key, the thing will start, run, and you're on the road. In order to choose which Rebel LS kit you're going to need to get your project up and running, you simply need to know whether you've got a Gen 3 style engine, which is the one with the cable throttle body, or a Gen 4 style engine, the one with the electronic throttle body. Once you've chosen either Gen 3 or Gen 4, a magical box will arrive with all of these parts in it, everything you're going to need to get the thing up and running. So there's no need to buy extra bits and pieces. Once one box turns up, that's it, that's all you're going to need. The car behind me here has got an LS1 Gen 3 5.7 litre engine with a cable throttle body. So I've chosen the Gen 3 kit, which is what's here in front of me, and this is what you get in the box. First thing out of the box is the engine management system. We call this the Rebel LS, the LS-specific engine management system that we've designed here at Haltech. Second thing out of the box is our terminated engine harness. This is the core of the engine harness, where one side of it plugs straight into the engine management system, then it comes out into the engine bay and plugs into all of the sensors on the engine. In order to make the thing as generic as possible, meaning that when one box arrives, you've got enough connectors to plug into all the different variants of the Gen 3 and the Gen 4 engine, we've configured the core of the harness with what we call breakouts. The first breakout that we've got, this side plugs into the core of the harness, then this side plugs into our idle control motor and our throttle position sensor. I know that because it's written right here, idle and throttle position. An LSU 4.9 wideband oxygen sensor that plugs straight into the engine management system, that's included. Then we've got our injector harness. This side plugs into the core, then over this side we've got our 8 injector connectors. Next up, we've got the alternator breakouts. So this engine could have been fitted with 3 different kinds of alternators. So we include the 3 breakouts, choose the one that plugs into your alternator, the other 2, just throw them out. A trans breakout. Again, this section plugs into the core of the wiring harness. Then, on this side, this plugs into the speed sensor on our manual transmission. And then the last breakout that's included is for our NOx sensors. One side plugs straight into the harness, the other side plugs into the factory NOx sensors. The reason why we do this with the breakout system is because it makes the harness a whole lot more modular. So if any individual part gets damaged, or if you decide that you want to replace your fuel injectors, instead of having to cut connectors off, you can simply replace that harness with a new injector harness that suits your new injector plugs. Included in the kit, you also get your inlet air temperature sensor. This inlet air temperature sensor should be fitted in the air inlet tract after the air filter, but before the throttle body. We've got a convenient aluminum bung that you can weld into that inlet stream, or there might be a part in your intake tract where that'll simply screw in. It's an M14 by a 1.5 thread. We've got a stainless M18 by a 1.5 weld-in bung for the oxygen sensor. This would go in the exhaust system so that our O2 sensor can screw straight in. A lot of people will already have one of these fitted to their exhaust system, but we include it just in case. We've got a Wi-Fi antenna. That connects to the bottom of the engine management system because you can connect to the thing with a USB cable or with Wi-Fi off your mobile phone or off your laptop. Lastly, we've got some mounting hardware, so we can mount the engine management system in a cool and dry and preferably safe place. And finally, we've got our battery lugs and our little rubber connections just to seal those off. These are direct battery connections to the engine management system, and the reason why we need a heap of battery connections to this thing, it drives the thermofan, it drives the fuel pump directly. There's no fuses in the harness, there's no relays. All of it is done within the engine management system, and that's one of the great things about the Rebel LS engine management system. It's driving the fuel pump directly, it drives the thermofan directly, so there's not all these extra relays and fuses and power wires all through the wiring harness. It makes it really nice and simple, and it gives the ECU direct control over those parts.
The installation of the Haltech Rebel LS can be split up into 4 main steps: laying out and plugging in the engine side of the harness, mounting and plugging in the ECU, running the battery cables to the ECU, then finally setting up the ECU through the NSP Wizard.
One thing I want to do before we get to the install on the car is just have a quick look at the base harness. One of the most important things to know is that there's a firewall grommet here. So this is the part that protects the inside from the outside. And if I just lay this out here on the bench, what I wanted to show you was the distance between the ECU connectors to the firewall grommet and then the firewall grommet to the first breakouts. That way you can get a bit of an idea of where you can mount your engine management system in the car. So the engine management system plugs in up here. Then if we measure this out, we've got about 2 foot, roughly 60 centimetres or 600 millimetres between the ECU connectors and where the grommet is. Then the breakouts from there, if we said roughly again 2 foot or 60 centimetres from the grommet further along, and you can move that grommet back and forward up the harness to suit your specific application.
The Rebel LS comes with 2 quick start guides, one for the ECU and one for the harness. We'd recommend getting familiar with these before you start your installation.
Now, it's always good practice to get as comfortable as possible when you're about to start working on your car. So the first thing I've done, I've taken the negative terminal off the battery just so that I don't get any nasty surprises. And the guys have fitted these zoomies to this thing. It's all for show. It doesn't make a huge amount of horsepower, but to work on the thing, I'm gonna pull all the zoomies and pull the headers off just to make it nice and simple. If there's anything else in my way, there's a bunch of fuel system stuff behind here that I might just pull out to make it nice and easy. If we put a little bit of work in now, it's gonna make the install go a whole lot faster.
And with that out of the way, let's get stuck in.
So now we're at the fun part. I'm gonna feed this whole part of the engine bay harness out through the hole in the firewall from the cabin to the outside, leaving the ECU connectors on the inside. So I'm gonna start by pushing them all through.
There's no right or wrong way to feed it through. Once the harness is out in the engine bay, it's a good idea to neaten it up, ready for the next step.
So the nicest thing to do is to plug all of our adapter harnesses onto the engine first. We'll just attack this one by one. We'll read all of the labels, figure out where they need to go, then we'll lay the harness in place, plug in as much as we can, then we'll just pull any slack in the harness for your particular application back and tidy them up in the cabin later.
First up are the throttle body connectors. At the bottom is the throttle position sensor, and up the top is the idle control motor. Next is the alternator harness. We've found the plug that we need and discarded the rest.
I've come to the knock sensor breakout harness, and this is something that we do need to talk about. The knock sensor breakout harness for the Gen 3 LS1 has got the 2 connectors that goes back into the Haltech loom. They're labelled knock odd and knock even. Knock odd, meaning the knock sensor for the odd cylinders, 1, 3, 5, and 7. Knock even, being 2, 4, 6, and 8. We don't do passengers and drivers bank because we don't know what part of the world you are in, and we don't know what side of the car your steering wheel's on. So the easiest way to figure this out, knock odd, 1, 3, 5, 7 is down this side of the LS engine. 2, 4, 6, 8 is down this side of the LS engine. This is also important when we're about to plug the injector harness on, just so we plug the injectors on in the right way, as well as the coil harness. We've got 2 coil connectors. One of them plugs into one bank, one of them plugs into the other bank. They are labelled as well. Make sure to plug them in the right way around.
With the knock sensors plugged in, next, it's time for the injector harness, keeping in mind, again, to match the odd and even banks.
And it's as simple as that. Once all of those sub-harnesses are plugged in, it's time to just rip into the harness. We'll just read all of the labels and just plug them in one by one, making sure to route them in the right direction, because remembering that once everything's plugged in, if you've gone over a brake hose or over a fuel line and you want to go under, you will have to go back through and touch that up.
The first connectors of the main harness to get plugged in are at the engine's rear, near the intake manifold. Here we have the cam sensor, oil pressure, and manifold pressure sensor. Located in the same area is one of the two cylinder head grounds. Connect the injector breakout to the main harness and the two ignition coil plugs to the respective banks. Pay particular attention when you're plugging these in. Moving to the front of the engine, connect the throttle breakout to the main harness. Coolant temperature and alternator are next, along with the second cylinder head ground.
Keeping in mind that some of the sensors between the Gen 3 and the Gen 4 engine are located in different positions, we've had to make the core of the harness to fit both engines. So if you've got any harnessing that is slightly too long, all we do is run it up the trunk of the harness, turn it around and bend it straight back into that particular sensor. This is with the exception of the crank sensor wiring. The crank sensor wiring is exceptionally long if you route it along the back of the engine to the crank sensor, which on this LS1 is located behind the starter motor. We have seen a lot of problems with the LS engines when we run the crank sensor wiring along the back, where all the headers have collected. It gets really hot down there, and that's one of the first places that we see burnt wiring harnesses. So we've made the crank sensor wiring super long so it can come along the front of the engine, then along the engine mount and plug in underneath. One of the exceptions to this is if you've got a front mounted turbocharger over here somewhere. In that case, you would want to pull that length back through and plug it into the rear.
Although a little bit hard to see, the crank sensor is located near the starter motor on this particular engine. While you're here, it's a good idea to connect the speed sensor to the transmission.
All of the dedicated GM LS sensors are all connected. We're looking really good. Things are looking really neat up here. We do have to make some decisions about all of these wires that are dangling along here. We've got a dedicated electronic thermofan output. This car's got one of those, so I am going to connect it. That's the one, it drives the thermofan directly. So it supplies power to the thermofan. We just need to ground the other side of the thermofan and we're done. We've also got an auxiliary output there, or a spare 25 amp output. That can supply up to 25 amps of 12 volt supply power to, well, anything you like. In this particular car, we're not going to use it, so I'm going to pull it back through into the cabin, and that one's going to sit inside as a spare. You could cut it off or terminate it short in the engine bay if you want, but that's really up to you. There's also a fuel pressure sensor connector. This car doesn't have a fuel pressure sensor, so that's not going to be required, so we can pull that back into the cabin and tidy that up inside. Then later on, if the guys decide to add a fuel pressure sensor, we could pop it straight back out and just plug it in. Anything that you're not using, tidy it up, terminate it, make sure that it's not going to rub through anywhere, put it inside or tuck it up somewhere nice and neat. Now that we've transitioned to inside the car to work on the wiring here, I know it still looks a little bit daunting because we do have a heap of connectors, but the good news is that most of them are going to be unused in most applications. We've got these two connectors that are extra outputs and extra inputs. This is where you might be wiring extra outputs, boost control solenoids, extra thermofans, extra water pump controllers, all of that sort of stuff. Inputs, whole bunch of extra pressure or temperature sensors if you want to do data logging, but you don't have to use them. So we're going to curl those up. They're going to sit to the side. We've got this pink wire. This one is absolutely critical. This is one of the most important wires in the car. It's labeled ignition switch. This is the one that when we turn the key onto the reds or IG2 or the second stage of ignition, we want this wire to have 12 volt supply power. We also, very, very important, we also need this wire to have power under cranking. So when all the red lights are up on the dash, we want power. Under cranking, we want power. This is the one that tells our engine management system to turn on and off. Further down the harness, we've got our 3 ECU connectors. They're going to plug straight into our Rebel LS ECU, so that's nice and simple. we've got our 4-pin Deutsch connector, which is called our CAN connector, or CAN communications connector. This is an expansion port where we can plug things in like the Haltech IC7 or UC10 Dash. We can plug in our CAN keypads. We can plug in extra wideband oxygen sensor controllers. We can plug in 4 or 8 channel thermocouple amplifiers, or a combination of all of them. So if you look up our CAN expansion products, you'll find a whole bunch of stuff you can plug in there. If you don't have any CAN devices, simply leave it alone. The next plug we've got down here is labeled APP, Actual Pedal Position. Because this thing is a Gen 3 LS1, it's using a cable style throttle body and a cable that goes between the throttle pedal to the throttle body. If it was a Gen 4 or LS2, it's using an electronic throttle. So that means that the engine management system controls the throttle blade. Then inside the car, we would need to have another sensor, an actual pedal position sensor. So that's a sensor that connects to the throttle pedal inside the car. But in this particular application, being a cable throttle, this plug's not used either. Last but not least, and another one of the really important ones, is our fuel pump direct connection wire. This one's capable of up to 25 amps. It connects directly to the positive terminal of your fuel pump. The engine management system will be monitoring the current that fuel pump's running. And we can even set a fuse current within the engine management system so that if it exceeds a certain current rating, we can set a check engine light or decide to shut the engine down if the fuel pump's pulling too much current. So to get the ball rolling in here, we need to find a nice place to mount our engine management system that's going to be away from mechanical damage, away from water, away from heat, away from feet, away from prying fingers. Then there's just one more step. We've got to get some battery cables onto this thing and we're ready to fire it up. And in order to determine how long those battery cables are going to need to be, we need to determine where we're going to mount the engine management system. I don't expect you to mount your engine management system front and center right in the middle here, but being a Haltech demo car, we've got the opportunity to do it. So I'm going to mount the Rebel right here. Because we've made that decision, I can now get our 4 AWG battery cables. I can crimp them, I can connect them directly to the battery, and then I can put them through a fuse to our positive and our negative studs here. Then route that terminated harness in and plug in our ECU connectors. We're so close to finishing this installation. We've got our black and our red 4 AWG battery cable here. I'm going straight from the battery. I'm actually coming out of the fuse box assembly because there's a heavy wire that goes from the battery straight to the fuse box assembly. Then I'm going to run my red wire in through the guard with the factory harness in straight to the VCU. The ground side is going to come off the negative side of the battery and run all the way through to the negative side. After feeding both of the battery cables through a gland in the firewall on the driver's side here, I've got them up through under the Rebel LS ECU. Now, pretty straightforward. Just take a little bit of care here. Don't absolutely reef on these nuts. About 2.5 foot-pounds of torque is all we're going to need. So nice and firm, but we don't need to get carried away. They're not carrying the whole weight of the car. And from the harness point of view, that's all it is for the Rebel LS. Our battery cables are on, our terminated engine harness is in. I'm going to sneak back to the engine bay and connect up all the stuff that I pulled off before to make that harness install really nice and easy. I'm going to double check everything. I'm going to check that my LS engine has got water, that it's got oil. Then let's set up the Rebel Wizard and try and get a first start out of her. By now, I'm sure you can tell that this is not your typical resto mod, and it's been done in a particular, let's say, flavor. That's brought with it a few challenges for this installation. So one of them is the air filter mounted straight off the throttle body, something that we typically don't see. Normally we'd have an air intake system. So we've got our inlet air temp sensor mounted in between the air filter and the throttle body. This is the best place for it. We get some airspeed there, and it stops that air temperature sensor from getting heat soaked if it's sitting in the back of the inlet manifold. It also highlights another point with our oxygen sensor. In a typical installation, I'd expect the O2 sensor to be mounted in the exhaust system after all of the collectors, so we're getting the average of all 8 cylinders of exhaust stream. If that's not possible in your application, we can put the O2 sensor after the collectors for one bank. If that's still not possible in an application like this, something is better than nothing. So in this car, we're going to put this one O2 sensor in these horrible zoomies so that we're at least measuring the air to fuel ratio of one cylinder. Something is better than nothing. The Rebel LS engine management system has got some advanced long-term fuel and ignition learning. So it's always monitoring this air to fuel ratio that's coming out and making adjustments to the fuel map. That's part of the beauty of the Rebel LS system. Once this thing's on and it's running, it's always looking at the NOx sensors, the ignition timing, it's always looking at the O2 sensor, and it's always making changes to all of the tune-ups so that your project runs as best as possible without having to hit the dyno.
Reconnect the negative terminal to the battery and open your laptop. Now it's on to the setup wizard.
Well, once you're sitting in the driver's seat, you've got your laptop connected and you plug your USB cable into your Rebel engine management system, you know that we're on the home stretch. Things are about to get serious. The second I plugged my USB cable in, little green light on the engine management system here lit up, telling me that I've got communication between the laptop and the ECU. I'm going to double click on my NSP, my Nexus software programmer software. She powers up and we're online, about to go into the Rebel LS setup wizard. Here we go. It's as simple as answering a bunch of questions before we finally get to hear this thing fire up. Vehicle name. They've affectionately called this thing Mod Max. This is a S15 Silvia with an LS1 power plant. Next. Okay, select engine. I'm going to search for LS1. This engine is a 97 to 2005 LS1 engine. Okay. It's automatically filled out that it's 5665 cc and the compression ratio is 10.5 to 1. Next. It has a stock camshaft. Next. It has a stock LS1 cable throttle body. Next. It has the stock LS1 manifold pressure sensor. If you're not too sure, once you've picked your LS engine, it's going to go through and it's going to pick the most logical choice. So if it's a stock style engine and you haven't modified any sensors, typically the channel up the top is going to be the right one. Fuel injector. Okay, this one's interesting. So the part number of the fuel injectors is conveniently written on the fuel injector. So I've already cleaned that fuel injector, wiped the sludge off it and had a look at the numbers on the side. The number on this injector was 12561462. So go and have a look at your fuel injector. Take a photo of it on your phone just so you've got that number. You can have a look here. We'll pre-fill that and I'm going to select that fuel injector. It tells me that it's a 30 pound or 315 cc fuel injector. Next, ignition system. I'm going to choose the ones that came standard on the LS, which it's already pre-selected for me. Next. Here we go. Okay. That's pre-filled everything that the computer needs to know about the engine. Now, the setup checklist is telling me to turn the ignition on. This is going to be the first time I turn the ignition on, so this is probably a good point to turn the ignition on, have a bit of a listen, have a bit of a smell, make sure we've got no smoke, make sure we don't have any trouble. So far, so good. The software is telling me, check the basics. Internal voltage check, tick. Our air temperature, measuring 25 degrees Celsius, tick. Coolant temperature, measuring the same as the air temperature, tick. Our oil pressure and our manifold pressure are all reading and they've all got a little green tick, so I'll click on next. Throttle calibration. Okay, so what's going to happen here, I've got my cable throttle pedal. I'm going to click on start. Do not press the throttle and click calibrate. Okay. 100%, click calibrate. Okay. And we're finished. So now the software knows the voltage of the throttle position sensor when the throttle pedal is off and when the throttle pedal is flat to the floor. Tells me that that calibration process is successful. I'll get to the next step. Throttle tests. Cable throttle position sensor. If I go from 0 up to 100, back to 0, up to 100, looking good. Next. check the fuel system. So I'm going to listen here and I'm going to go start the test. I can hear the pump running in the background. That sounds pretty promising. Down here on my Rebel, I can see my fuel pump output light has turned green, and then I'm going to stop the test. The light on the Rebel turned off. Did the fuel pump turn on? I'm going to say yes, it did. Get a successful test there. Next one, thermofan. Start the test. I can hear it turn on. The fan light on the Rebel's turned on. Stop. Did it turn it on? Yes, it did. And we get a successful test again. I'm starting to get a little bit confident this thing's going to run. Okay, next step. It's telling me start the engine. It's then going to check injectors, check ignition, check the knock sensors, check the manifold pressure. There's no need to choose the trigger system. So Gen 3 engines typically had a 24 tooth trigger on the crankshaft with a single tooth on the camshaft. Gen 4 engines typically had a 60-2 on the crankshaft with 4 teeth on the camshaft. In other engine management systems and in other parts of the Haltech range, you need to select which particular trigger type the engine has. Because the Rebel is a specific LS engine management system, we've configured it so that once we crank the engine, it's going to look at the crank and the cam sensors and it's going to select the right crank and the right cam sensors for us. So we've taken that whole part out of the equation. Something else that's wonderful about the Rebel LS system, if you've got a Bitsa engine, so if you've got a different crankshaft and different cam position sensors and different trigger types, if you happen to have put an LS1 crank with an LS2 cam sensor or a LS2 cam with a LS1 crank or whatever the case, this ECU will figure it out and she'll start right up and run. We support all the different combinations of LS trigger type. One thing that you do need to do before you follow this, start the engine. Make sure that she's in neutral, make sure everything's safe. Cross your fingers, here we go. Complete. There you have it. It's even surprised me that she's up and running through the Wizard. We've come to the end. We've got no engine check lights, no trouble codes. So the next thing I'm going to do is start it. I'm going to bring it up to operating temperature. I'm also going to be looking at the air to fuel ratio here to make sure our oxygen sensor is reading correctly so that our engine management system can look at the actual air fuel ratio, then look at our target air fuel ratio, and it'll make adjustments. It'll make short-term and long-term adjustments so that our actual air to fuel ratios always meet our targets. It's continuously doing this in the background. So the longer the engine runs for, the more load sites that the engine operates in, the better the tune-up is going to get, the better the drivability is going to get, the better the fuel economy is going to get. And it doesn't forget this every time you turn the keys on and off. The long-term fuel trim is remembering how much error there is, and it's always remembering those changes. So it doesn't need to keep making the same error over and over again. Once it makes that error, it learns from it, it puts a correction in the background, and then it keeps going. This is one of the reasons why you don't need to get your Rebel LS engine management system straight on the dyno. Once she's up and running, we're out on the road driving this thing. For those of you that don't have an LS engine or don't have a Rebel LS ECU, but you've stuck around for this entire video just to see a dyno pull with the zoomies on this stock LS1 engine, well, I feel guilty not giving you that. So it's time to roll it onto the dyno, we'll run it up, we'll see what sort of power it makes and see what the thing sounds like.